means derive. Derive that v is equal to omega arrow. V here stands for linear velocity. Omega here is the angular velocity. Arrow is the radius. So we're going to interpret this, and this comes under mechanism. And under this mechanism, that's what we call curvilinear motion. Curvilinear motion is divided, or has three types. One is the simple harmonic motion, and we have another one to be the circular motion, and another one to be the rotational motion. All right. So under the circular motion, we're going to solve this problem. You can still use the approach of a rotational motion to also solve this. So in one of the videos I'm going to detail everything about this. Okay, so but here we're going to be direct to the point. So how can we be able to solve this particular expression? What is this actually telling us? This is a body from point M is to rotate around this cycle. And if a body is to rotate around the cycle, that's what we call the centripetal force and the centrifugal force. We're going to explain the concept of that too. All right. But in ideal state, if I'm whiling a stone like this, and what if the stone cuts? What happens? It will move in a tangential direction against this circle. So at this point, if a body moves from this point M to this point B, it will sweep an angle called theta. And this S is indicating the length of an arc. So S here is the length of an arc. An arc, or some can call it distance or displacement as the case may be. Then arrow here is the radius. And then finally, this theta we are having here is what we call the angular displacement. The angular displacement. So now I have shown or explained these parameters. This is point O, which is the center of the circle. So how are we going to solve this or derive this expression so that it will give us this? Notice that in the normal expression or definition of this, you should just take note that S, which is this displacement, has a relationship with this theta, which is the angular displacement. I also have a relationship with arrow. What could be the relationship? This is the relationship. Theta is equal to S over arrow. S over arrow. You can make this our equation 1. And at that point, you can also make this S to be the subject of the relation. How do I achieve that? I will say, let's cross multiply this, then S will be equal to theta arrow, and this is equation 2. All right, having gotten this expression, we need to do something also. In linear velocity, we know that linear velocity V is equal to the d over s, or in some cases you can use time. This d is talking about the displacement. Some could call it distance. Distance or displacement, the term can be interchanged, but the difference between distance and displacement is that distance is a scalar quantity, whereas displacement is a vector quantity. So you can also write this expression as V equal to S over T. It's still valid. S is standing for displacement. All right. So again, we have a definition of this. This symbol is for angular velocity, and it talks about the change of angular displacement with time. So notice that this is linear velocity, this is angular velocity. Linear velocity has displacement over time. Angular velocity has angular displacement over time. All right, let's see the relationship between these two. I can approach this in two ways. The first way, from this equation 2, I will have to introduce this concept that V, or you can say recall. Let's put it that way. Recall that V is equal to S over T. And this is equation 3. Now from equation 2, we have S equal to theta arrow. So that means anywhere I'm seeing S here, I can substitute theta arrow in place of this S. So we have V equal to, in place of this S, look at S here, it's having theta arrow. I'll have theta arrow all over T. All right, that makes sense. This is equation 4. So at this point, you can see that theta over T, we have arrow, theta arrow over T, can also be splitted in such a way that this theta over T has a definition. theta over t, look at it here. Theta over t has the definition to be for this angular velocity. So in place of theta over t, I could just replace omega, then bring down this arrow. And this is the expression we are to derive. Alternatively, from this point, I could say, since we have s equal to theta arrow, I could take the differential form of this expression. What do I mean? I can differentiate the two expressions with respect to t. If I differentiate this first one with respect to t, the left hand side I'll also differentiate theta arrow with respect to what? T. Alright, and the differentiation of this is giving us the definition of velocity. And of course, it defines velocity as a change in displacement with respect to time. So in place of this, I can replace it with v. And at this point, it's just like when you're dealing with implicit derivative. I can't differentiate the radius because the radius is constant at all points. So I have to take the radius out and differentiate this theta, the angle, with respect to t. Of course, v is equal to arrow. What is the theta over dt? The theta over dt is for omega. This omega can also be written in the differential form as omega equal to d theta over dt. Alright, so in place of d theta over dt, I can replace it with omega, which is this. So this expression and this, they are the same. I can change it because it is multiplication. I can still write it as omega arrow. So that's how we can be able to derive this. I hope this makes sense to you. Please, if you enjoyed the lesson, please like my video, subscribe to my channel, and also turn on the notification, share if necessary. Thank you, and still subscribe as we are going to solve more problems. If you turn on the notification, there's an advantage of that. The advantage of that is that you always get notification whenever I post new video. So when you subscribe to the channel, by the right, you see notification bell, turn it on and get more notification. Thank you, and stay tuned. Peace.